A quadratic equation of this form, so standard form, has two solutions, right, which we expect for a quadratic, and we need to find possible values for A, B, and C. So we're given the solutions, we need to sort of reverse engineer from that what the possible quadratic equation could have been. And now there's actually infinitely many options here, but let's just go for one, right? We don't have time to be here for the rest of our life, so let's get to it. So starting with the solutions, maybe just a side note, let's just remind ourselves how we go about solving for a quadratic equation, and then we'll do the steps in reverse. So for example, we could solve this quadratic equation, we could factorize it. Two numbers that multiply to -3 and add to +4. That would be 3 and 1. Right, so we factorized it, and now we can solve by setting each set of brackets equal to 0. Because the product of those two must equal 0, so one of them has to be 0. And then we solve for x. So in this example, we started with a quadratic equation, factorized it, set the brackets to 0, solved. In the question, however, we're given the solutions, so we're starting down here. We need to then go back to factorized form to then expand it to get the original quadratic equation. So I'll just leave this here to guide us. So let's start with the solutions. They are -½ and 2/3. Now to go from the solutions to the factorized form, notice that we have our brackets equals 0, and we have x in both of them. And then the constant next to x is the solution, but it's the opposite sign, right? And that's because when we set it equal to 0, we flip the sign around. So here, instead of x -½ we do x +1/2 and x -2/3. Right, and we can check if we were to solve this by setting these brackets equal to 0, we would get x equals -½ and x equals 2/3. So we've taken the solutions and used them to write the quadratic equation in factorized form. However, the question is asking for standard form, so now we can expand our quadratic. So we get x times x squared, x times -2/3, -2/3 x, 1/2 times x plus 1/2 x, 1/2 times -2/3, -2/6, and that equals 0. All right, now let's group our like terms in the middle there. So -2/3 plus 1/2 x. If you're not a fan of fractions like me sometimes, we can just do it in our calculator. So we can do -2 divided by 3. And we can add 1/2 or 0.5. And on our calculator, there's the button above 8 to convert it to a fraction. So that's -1/6 x minus 2/6 equals 0. So this is looking a bit better. So it is in standard form, right? We have our x squared term, we have our x term, and a constant equals 0. So from that, we could say that A equals 1, B equals -1/6, and C equals -2/6, which is -1/3. All right, so that's a perfectly valid solution. So from here, this quadratic equation right here, you can actually multiply it on both sides of the equation by any number you want, and you'll have a valid quadratic equation that gives us those two solutions. A common question is, let's say A, B, and C are whole numbers, right? So it's not letting us have them in fractions. Well, we can get rid of the fractions by multiplying both sides by 6. That would get a 6x squared minus x minus 2 equals 0. Right, so again, we got this quadratic equation. It had fractions in it. I'm just extending the question a bit here, just saying, well, what if we weren't allowed fractions? But we were only allowed integers or whole numbers. We can then multiply it by the lowest common factor of 6 to give us 6x squared minus x minus 2 equals 0. And in this case, a would be 6, b would be -1, and c would be -2. And these are both valid solutions.